focuses again on things that are parallel, things that are perpendicular. All right, right on top. All right. Everybody know what the title's got it?
So, she's in the middle of the lesson and all this thing.
Okay, let's go on. Old news. Okay, the first theorem to build an example. Actually, I need to put some arrowheads on them to make them into lines. Okay, and let's call the lines A, B, and C so that it's easy. Yes, draw the lines so that you are building an example for yourself. Okay, it says if two lines are parallel to the same line. So if A is parallel to B and C is parallel to B. Two lines, A and C are both parallel to B, the same line. So A and C are my two lines, they're both parallel to the same line, which is line B in my picture. Then, what's the theorem say the conclusion can be? Then they are parallel to each other. Which ones are parallel to each other?
A and C.
A and C would be parallel.
I got it, guys. Don't worry.
Congratulations.
You remember the transitive property? This is kind of like the transitive property, but with parallels.
Oh. Okay.
Very much the same. So if I were putting the arrowheads on, if you need to see it in that form, A is parallel to B. C is parallel to B. So I'll put 2. C is parallel to B. So then A is going to have to be parallel to C also. Okay. Examples in the room. I think a good example can be found on the ceiling.
Oh, yeah, all right.
If you use certain dividers,
Is that one?
if the first one is parallel to the second one,
Then
and the second one's parallel to the third one,
Then the third is parallel to the first one.
correct. Austin,
So that like pictures.
that like fixture?
Yeah, it's parallel to that one.
Okay.
And that one's also parallel to that one, so that one's gotta be parallel to that one.
Correct. Okay, so you can make up a lot of examples. You have to have 3 lines in order to do that one, okay? All right, then we have one that's called dual perpendiculars theorem, based on this one. Okay? So let me fix up the picture. Here's our lines. And we'll call A, B, C. All right, 2 lines perpendicular to the same line. So let's make A perpendicular to B and which other one? C. See, A perpendicular to C. So A is perpendicular to B, A is perpendicular to C. So we have 2 lines, A and B, or excuse me, B and C are the 2 lines that are both perpendicular to the same line, which is line A. Then, what's the conclusion say?
Be parallels.
That they are parallel to each other. They, B and C in this picture, are parallel to each other. Not that B and C are perpendicular to each other. B and C are parallel to each other. Now this one you can reason through with that converse of the corresponding angle postulate. Because if this angle is 90 and its corresponding angle is 90, that converse said then the lines will always be parallel. And again, you can create examples of that in the room. Again, the ceiling gives me a lot of perpendiculars and parallels. So if you've got, let's see, one that's going forward maybe, that forward one is perpendicular to this first bar and it's perpendicular to the second bar. So the first and second one are parallel to each other. So you can set up the 90 degrees easily. That's called the dual perpendiculars. So So the way I remember it is from its title. There's two perpendiculars to get the parallel, whereas the last one was there's two parallels to get another pair of parallels.
Hold on.
Hold on.
Please, sorry.
Okay, guys, time to go.
Okay.
Anybody else?
Oh, thank you.
All right, we did some classroom examples already. Now let's summarize yesterday and today so that you realize what we did. What are the 6 theorems or postulates that show that two lines are parallel? So the things that we've talked about yesterday and today, that in the conclusion says, then the lines are parallel.
Okay, so.
Okay, yesterday, what did we have that said, then the lines are parallel? Look at your notes if you need to, it's right in front of you. Give me one.
Alternate interior angles converse theorem.
Okay, he did get converse. Okay. Another one that concludes the lines are parallel, Colton?
Is this something that
Alternate exterior converse theorem.
Alternate exterior angle converse theorem. Another one, Austin?
Congruent angles converse.
Congruent, I don't think that's right C word. What's the C word he needs?
corresponding?
Damn, why do I keep thinking it's congruent?
They are congruent, but yeah, the name is corresponding. Corresponding angle, converse, that one is the postulate. Okay? Dustin. Same side interior angle, did you say converse?
Yeah.
All right,
That
sorry,
should be our word.
sorry about the blank out there.
Converse is the word of the week.
Yep, it was the word of yesterday's day. Okay, then 2 more. Okay, and do you remember the symbol for parallel? Straight up and down, same. So dual parallel theorem, to understand my shortcut. And
Dual perpendicular.
and what's that symbol for perpendicular? Upside down to you. So if the question is asking, are the lines parallel, these are the 4 explanation or reasons that you could give. If it doesn't fit one of those, then nope, the lines are not parallel. So those are the 6 ways. So yeah, good to have that summary because I think part of your assignment is probably going to ask, are the lines parallel? And explain. So if it's a yes, these are your possible explanations. Any of those that we need to review right now? Everybody got the notes? Okay, so if I would put an angle here as 110 degrees, and then this one as 110 degrees, it says explain how you would show that the 2 lines are parallel and explain your reasoning. Don't shout out, but look at your list there. Can we get the lines parallel and give me
Yeah.
explanations?
Yeah.
Tristan, explain me through it.
Alternate exterior angles converse.
Okay, so that one didn't have too much to it, right?
No.
Okay, what if I would, instead of that one, give you this one? Are those corresponding angles?
No.
No, upper left, no, they're not corresponding. Alternate interior, alternate exterior, same side interior. Perpendiculars, dual perpendiculars or parallels? No, but think some more, okay? Vertical angles, which one do you want me to go vertical from? 110, are these angles vertical? No. But we can do something maybe with vertical angles to help us out. Austin, which one do you want me to do?
Alright, so the 110, its vertical angle would be 110, since it's, and then since it's the same side interior angle, it's the 70, you can add those together to equal 180. Boom.
And boom, we can use,
It's the supplementary.
yep, what's the name of it? Which of the 6 is he really telling me I
Same side interior converse.
There
Same
he
side
goes,
interior
he's
angle
got
converse,
it,
okay?
he's got it.
So we were kind of stumped with just the ones I gave you, but some things we've studied, you can do vertical angles that are congruent. You could have done a linear pair, like maybe this one, the linear pair here have to be supplementary. So this would be 110. Then you could use the corresponding angle converse to come up with it. So you can do some various things based upon what we started with. Okay? Determine which lines, if any, must be parallel. So is it lines A and B that are parallel? I have to put some numbers up here yet. Is
Yeah.
it C and D that are parallel? So you're gonna decide which pair it is. And I'm gonna give you this angle as 130 degrees. And then I'm giving you this angle here as 130 degrees. Okay, don't shout it out, let people think. Okay, with those angles the same, is it lines A and B that are parallel, or C and D that are parallel, or neither? And it might help you to, in your mind, draw those two angles and see what's left out. Because that actually will help you do your pair. So if anyone's struggling a little bit, here's angle 130, here's the other 130. Does that help highlight which would be the pair? Brianna? Figure out which pair would be the parallels? A and B. Reason?
Because 130 is
On which out of that list of 6 things, did you put those last notes down? Okay, out of those 6, there were 4 converses and 2 dual theorems. Which one is it that supports this? They were the converses from yesterday and the dual things from today. Okay, do we have 2 lines parallel to the same line? 2 lines parallel to another line, we don't have enough parallels for that one. It's one of the converses from yesterday. Which pair of angles are these, Rihanna? Are they corresponding, alternate interior, alternate exterior, same side interior? Right. So what she needs to be using to get the lines parallel is the corresponding angle converse postulate. All right, she got that one right. Did everybody else?
Yeah.
Okay, let's go with an angle here as 80 degrees and an angle here as 80 degrees.
Ooh.
I'm kind of erasing my A and B. So is it lines A and B that are parallel? Or C and D that are parallel? Or neither one? Kristen and Dustin, you gotta take a look at it. Dylan, what do you think?
C and D,
C and D, do you have a reason?
because alternate interior angles covers there.
Correct. C and D would be your parallels. And he said the converse of alternate interior angle theorem. Correct. Okay, next one. What if I go 120 degrees here, 120 degrees there? Trace the 120 degree angle in each one, figure out what the pair of lines is. Can you take one line out of the picture and still have both angles formed? You really can't, can you?
So it's neither.
So this is a neither. There's no way I can eliminate one line to get the pair and have both angles still formed. So this was a neither.
Yeah.
Can't come up with that one. Okay, let's put the 120 here then. Which lines are parallel? No again? Correct. No, I needed to give you another one here or here. All right, so let's go with this one then. Does that make it work? A pair of lines and a transversal.
Oh,
Okay, which ones are the parallels?
A, B,
No, C and D.
no, C and
What are
D.
you doing?
Yep, C and D, okay. C and D would be the parallels.
And the alternate exterior angles converse
All right, so those 6 theorems. Find the value of x to make the lines parallel.
There's no X.
I know. 3x goes right here, and then let's go with 5x. here. What value would make the lines parallel? What kind of angles are those, Kylie? Supplements because they are called same side interior angles. So we kind of talked about this earlier today. So we would need to go 3x. How do you make them supplements? 3x equals 180?
3x plus 5x equals
Okay, plus 5x equals 180. And I think when we solve that, we'll have to take 180 divided by 8, which I think is a messy number.
Yeah.
So whatever that comes out to be, I'll just say we have to do that. But we did some of those earlier. Okay, on this one, I'm going to tell you that this angle is 120, and then this angle is 120. What parallel lines? Is it A, C, or F, or B and D? Which ones are the parallels in this picture? Again, do what we were doing in that simpler picture. Make the 2 angles that are formed, and that should help you figure out which are the parallels. Mitch, which are the parallels? A and C. Correct. Reason? Did you say converse? Okay, I say converse, right. Okay, so there would be some diagrams like that where they've got more lines to it. Let's do the postulate and then the constructions. I think that's what comes after. Okay, there's 2 postulates, a parallel postulate and a perpendicular postulate. Seems like we're getting the hang of it, at least for those that are participating with me a lot. Parallel postulate says if there is a line and a point not on the line, so that's what we're going to fix up our picture to have. There's a line and there's a point that's not on the line. It says then there is exactly one line through the point parallel to the given line. Picture will look real good. Right there's the example of line that I think is parallel. Now why does it say there's exactly one? What would happen if I move that line further up or further down? Wouldn't go through the point P. What if I kept it on P but tipped it a little bit?
Nope, not parallel intersect.
Not parallel anymore, they would intersect, right? So there is only one correct line that you can get in there parallel. Then there's also a perpendicular postulate. Are we done with the parallel postulate? Okay, there's a perpendicular postulate that sounds almost the same. We start with a line and a point that's not on it. I'm going to try and estimate where I think 90 degrees would be. Trying to make it so that that's 90 degrees. It has to go through the point P, and it has to make a 90 degree. So if I tipped it too far one way or the other, it wouldn't be perpendicular. If I kept it at a 90 but slid it to the left or right, it wouldn't go through the point. So there is only one specific 90 degree angle goes through the point and remains 90 degrees.
I don't understand why, how people figure this out, like, are they just sitting at home going, I'm gonna see if this line intersects PQ, and then I'm gonna see, then I'm gonna divide that by 90, I wanna see this.
Yeah, they're just curious people. They probably were wearing togas, because they would be back in the Greek and Roman times. So it's appropriate for today,
Same
maybe.
with the guy that invented pi, I mean, how do you have that time?
He just sat down and started writing numbers.
Yeah, just wondering, okay, if I go around this circular whatever they had, and if I go straight across, what's the comparison? And does that work on something bigger, something smaller? So
What about the Earth?
there's probably things that you might wonder about, but you just don't take the time to really explore it.
Time like never
Nope.
change and never.
It doesn't end, doesn't repeat,
I wonder why video games are so fun, but I never.
so that's what you're working on,
Wonder why those
trying to figure out which is the most.
figure that one out.
Those are video game,
I
the
just-
zeros and the ones, okay?
Yeah. We're done with this screen?
Go all matrix.
Okay, so let's do our constructions. I think we did these actually. We did the perpendicular, we had a line, I'll just sketch it and see if you remember. The point on the line, we swung the arc,
Oh, yeah.
and then from those we made the X. Okay, we did that one. The point not on the line, that was this one, where the point's not on the line. Again, we started there and made an arc. From those two, we made an X. Recall those? Okay, that was a bad picture. But we're gonna put those together and make our parallel lines. So let's do the second one first, and then we might wait on the first one till another day. Let's do the one using perpendiculars, because it goes with our lesson specifically today. So grab a compass and straight edge. And on your paper,
Yeah,
still got a bad one?
that compass though.
Oh, yeah, I did.
My eyes twitching like I can
Pencil out. That's good. Yeah,
Seriously?
the compass away, and
I
I
don't
don't think
think
anything.
I can.
If I had some will or something.